Hey, it's Zach. Welcome back to the Spacetime podcast by spaceexplored.com. This week is a very special episode. We are interviewing Jaakko Karras from NASA JPL. That's NASA's Jet Propulsion Lab. And what Jaakko's work is he works with a team that has developed what's called Ingenuity, which is a Mars helicopter. And on July 30th, United Launch Alliance, ULA, will send the Mars rover Perseverance and the very first Mars helicopter, Ingenuity, to space. And so it will leave Earth, arrive at Mars in February 2021. So it's a long journey. And these launch windows are only available every 2 years. So it's very special that they are able to meet kind of the demands of the moment and pull this off, even with sort of a global pandemic happening right now. And what Jaakko shares with us is very great insight into sort of the origin of this project, what it will actually be like to work on it, not just so far, but while it's headed to Mars, the helicopter. It's a part of the Mars rover, so there's lots of work to be done even before we get to Mars with this helicopter, and it's really interesting insight into what the process is like, how someone kind of follows a path of robotic engineering and and makes this possible. It was a really enjoyable conversation, and I'm joined by my new Space Explored colleague, Seth Kurkowski, and so he's on the video as well for the podcast. You'll hear him in part of the episode as well. I asked Seth to join because, frankly, speaking with someone like Jaakko, I was really out of my depths in terms of confidence in talking about such a complex subject. But thankfully, Jaakko managed to break it down in terms that I can understand, and hopefully everyone follows along with. And I really enjoyed it. So if you enjoyed this episode, please subscribe to Space Time in Apple Podcast, Overcast, Spotify, or on YouTube. Really appreciate that. And next week is the actual launch for Mars Perseverance, the rover, and Ingenuity, the Mars helicopter. And so I'll be in attendance at NASA and Kennedy Space Center then, and we'll bring you even more interviews next week. So we've got a lot planned for next week. So stay tuned, stay subscribed, and in the meantime, I hope you enjoyed this episode with Jaakko Karras of NASA JPL.
Hey, Zach.
How are you today?
Good. How are you?
So Jaakko, this is Seth Kurkowski. He's my new colleague, and he's got way more experience in space stuff than I do. So he's like my backup in terms of knowing what I'm talking about.
All right. Nice to meet you too, Seth.
Good to meet you.
Yep. Cool. Well, just to start off, kind of how are you feeling? In the less than a week before the launch.
Super excited. I mean, it's many years of work to get here. There's a little bit of anxiety, sure.
Sure. Yeah.
Right. Launching first of a kind spacecraft into space will be operating it pretty soon after launch. So a lot of firsts coming pretty quick here. But yeah,
Yeah.
It's a huge accomplishment for the team. We're really excited.
Yeah, and just kind of as a primer, the team that you work on is the team behind Ingenuity, the Mars helicopter, which, as you say, is the first of its kind. It's the first time it's actually, I guess, a test flight, right? So that you can determine, is it possible to fly a helicopter on Mars to do different tasks? One question I have before we kind of go more general is, do you have a sense of like what the chance of failure is? Because my understanding for a rover is that it's like tested to 3 times its mission duration. And so you kind of have that like 66% room for this to work. For this, it kind of sounds like there's a possibility that it's just like might not work. So do you have a sense of like the kind of percentage there, or how confident are you in this happening?
Yeah. So you said it. You said it well. It is an experimental aircraft. It's considered a tech demo. So
Right.
It is working to prove out a lot of very new technology. Obviously, a very unprecedented concept, flying on Mars. It's hard to put a percentage on something like that. Obviously, we have done a lot of testing. Past several years have been almost continuous test with different flavors of the vehicle. So we're confident that it's going to do what it's supposed to do. But the thing with spaceflight is you don't really know until you do it. There are so many things about the environment that sure, we have good models. We've been to Mars before, but we're just not going to know for sure until we get there. The rover, not being a tech demo, right? The rover being a flagship mission has done even more testing than we have. So they have that higher confidence, higher margin on things.
And building on the experience with Curiosity. So it's kind of like Curiosity plus in terms of experience. There's no kind of what came before Ingenuity. It's this is the tech demo, right?
This is the first one. Mm-hmm.
Mm-hmm. Another question before we get more general. From my understanding, so this the Mars 2020 launch, ideally, kind of weather permitting and conditions permitting, launches on July 30th, and it's like February 18th or so, 2021, when the landing is expected. So to go from Earth to Mars. I know you said that the team's been working on Ingenuity for years. This is a result of that. What do you do in the month-long process between like launch and landing? Is there work to be done? How does that affect like your sleep at night for the next several months?
There's always work to be done. So we on the helicopter team, we definitely have a couple of phases to this mission. We do have operations that we do need to do during cruise. Mm-hmm. The helicopter has a small battery in it that needs periodic charging to keep it in a healthy range. And so we'll be doing that periodically. At the same time, looking at just overall system performance, so electronics operating in the radiation environment, watching thermals, making sure that things aren't getting too hot or too cold. And parallel to that cruise op phase, there's also still a fair amount of parameter tuning and modeling and simulating, getting ready to actually arrive at the surface. Right. Because when we do arrive, I should say once the helicopter is deployed, we only get about a month, 30 sols to do our experiments. So we have to be ready to operate with pretty high tempo.
Sure. Yeah.
Get everything done.
So I imagine that helps out with kind of the concern and worry about what could happen in several months, because every day you're still on task related to it, and so that work probably keeps your mind off of, this is a long process before it arrives, and hope it goes well.
Yeah, we'll certainly have we'll have our tasks to keep us busy. Yeah.
Sure. Yep. And Jaakko, backing up a little bit, can you kind of describe what you do, what NASA JPL is, your role at NASA JPL and on the helicopter team?
Yeah. So NASA JPL, NASA Jet Propulsion Lab, really specializes in the design of robotic spacecraft for NASA. That's really JPL's niche. So JPL, of course, is known for the Mars rovers, this latest rover, Perseverance, is really following in a great legacy of that kind of work at JPL. So my role at JPL is I'm a robotics electrical engineer. Mm-hmm. So I came onto the helicopter project from that background, from a robotics background, which is interesting because the helicopter is truly a very autonomous vehicle. It's a helicopter, but helicopter on Mars isn't something that you can just joystick from Earth. The time delay is way too long, so it has to do a lot autonomously, and that's sort of where I came in. Yeah.
Cool. And I know from your experience, you've worked on something called Puffer, which is an acronym. Ingenuity is nice in that it's just a cool name for a Mars helicopter. Puffer, that's cool. What does Puffer stand for, and what's your experience with Puffer?
Yeah, I'm glad you looked that one up too. So I I I did my graduate degree at UC Berkeley, where I was working with a lab that specialized in the um, design of origami folding robots. So these are small robots that um, you can manufacture relatively quickly and inexpensively in large quantities. So when I came to JPL, I brought that uh, uh, background with me and sort of started looking for applications for that in the space exploration domain. And so what Puffer is it's an origami inspired, um, roughly size of your palm rover concept. The idea being that you would pack something like a dozen of these onto a larger mission in a little shoebox sized volume, and then eject them sort of like one off the top of a deck of cards, and have them unfold, become operational, and then cover that last 100 meters, from the parent spacecraft to some extreme terrain that's of high science priority, high science value that you wouldn't necessarily want to send the primary spacecraft into for either fundamental mobility reasons or risk reasons.
That's awesome. And I guess it's just by the idea of having multiple versions of these smaller palm-sized rovers, then the opportunity, or I guess the consequence of losing one is you've got multiple, and so it also it lowers the risk of messing up a mission, and that if you lose like your primary spacecraft, like you mentioned, then it's kind of game over. But if you've got a high number of smaller rovers like this, then they're a little bit more expendable in what they can do.
Yeah, that's absolutely right. Yep.
Yeah, that's awesome. What I'm so impressed with your work and what the team is doing. Um, how do you go from, well, I don't know where you start from, but how do you get to where you are? What sort of motivates you, inspires you, pushes you in this direction, to be so interested in robotics and to eventually be a part of the team that's sending a helicopter to Mars, basically?
I think I've always from very early age just been very interested in creating things, building things, learning how things work. Uh, Interestingly, one of my earliest memories of being exposed to space exploration was reading about the Sojourner rover.
Okay, yeah.
Uh, Back, I must have been 8 or 9 years old. Um, just sitting, some spare time at summer camp, and I picked up a magazine, and there was this article about how humans had launched, landed, and operated a small rover on another planet, literally millions of miles away, and that just blew my mind. Uh,
Yeah.
Now, I think that probably what piqued my interest there was more the robotics and the technology at the time than it was space exploration.
Sure.
And so from there, I went on to eventually become very interested in computers, and I started programming and um, did high school robotics through the first program, and went to college to study engineering and to grad school to study robotics. And so up until that time, I was very much a robotics guy.
Right.
But towards the last few years of grad school, this was right around the time that Curiosity had landed, and we'd all followed that very closely. I decided that wow, JPL is doing some really compelling, some really challenging things with robotics.
That's where the
And
action
as a
is. Yeah.
roboticist, I'd like to work there. And so, fortunately, I was able to make a contact. And a few months later, I was sitting and working in one of the buildings that had actually been very, very instrumental in the design of the Sojourner rover. So it was an interesting,
Right. Wow.
connection. Cycle back to the things that I first read about when I was 8 or 9 years old.
That's awesome. When I was, I think I was around 96, I was 5 years old playing Pokemon, and like that was like what I was doing. So,
Yeah.
um, I love that that connection to what's about to happen. That's really cool. Um, Seth, do you have anything you want to ask about in the moment?
Yeah, so you talked about Sojourner, right? And it being the tech demo for rovers on Mars, landing with Pathfinder. So and this being the new tech demo being landed on with a rover, now kind of the next step possibly in Martian exploration. What is kind of like the spirit opportunity do you like versions of a helicopter on Mars do you think we might see if this tech demo goes perfectly fine?
Yeah, you know, really hope that this tech demo opens the door to larger rotorcraft on Mars. We hope that it unlocks what we refer to as the aerial dimension of that planet. So the fundamentals show that it's absolutely possible to build an even larger helicopter type vehicle. So that would be one that hopefully carries an instrument suite that can fly, you know, higher, faster, further, just cover more terrain. And the motivation there really is that, you know, an aerial vehicle carrying instruments with the ability to do its own science can really get you to new terrains that the rovers, something that's inherently operating on the ground, cannot access. So yeah, there's absolutely a hope for the you know, Mur class of helicopter, if you will, if this is successful.
That's awesome. I guess that's the size of the rover. So it's, you know, same conceptually as Curiosity. So it's the size of, I guess, about a Mini Cooper or so. So a small car. Ingenuity is a portion of that. How would you characterize the size of the helicopter itself?
Yeah, the helicopter is quite small. It has to be,
Sure.
To pack into the rover. So it has a rotor diameter of about 4 feet.
Okay.
Which sounds large, but the fuselage of the helicopter itself is actually only about the size of a baseball, maybe a, you know, grapefruit.
Mm-hmm.
So it has large rotors, as you know, as you might expect for something that needs to generate sufficient thrust in a 1% atmosphere. But it is very, very light. So fuselage the size of a baseball, total mass about 4 pounds.
Mm-hmm. Oh, cool. And what kind of technology is packed onto it? So from my understanding, kind of there are, I guess, you know, 5 or so primary objectives for Ingenuity. The first is demonstrating flight, and if that goes well, then each next step is longer and longer, kind of more challenging than the one before it, because you don't want to like lose it on the first mission or first objective. What kind of technology is on board Ingenuity, and what are those objectives that it has once it reaches Mars?
It is certainly, you know, a feature packed or a technology packed little vehicle. The interesting thing about it, sort of coming from a engineering standpoint, is that it has to do a lot, right? It has to be both, you know, a viable independent spacecraft. It has to generate its own power, manage its own thermals, you know to wake up at the right times to communicate with Earth, you know, through the rover. It has to be a helicopter, right? It has to fly in the 1% atmosphere, and it also has to be an autonomous vehicle. So there's a lot of requirements crammed into those 4 pounds. So technology wise, it's really been all about keeping the mass down and miniaturizing everything. So it's flying, interestingly enough, a lot of commercial parts. So not the traditional radiation hardened parts that, you know, you might find on most spacecraft. You know, it's flying a smartphone grade processor. It's flying smartphone grade cameras. You know, all of it just motivated by the fact that, you know, those parts in the last several years have really come down in mass and volume, while at the same time keeping performance at a very, very high level. So we take full advantage of those developments, and yeah, a lot of new technology packed in there. Will be a lot of firsts demonstrated once we get.
Yeah, I love that perspective, because in 1996 with Sojourner, you couldn't do this. Like, you know, you couldn't send your iPhone to Mars and like have it, you know, basically record, which is kind of, you know, how you're describing what this helicopter is like with consumer, you know, kind of facing parts. it just wouldn't be possible. So,
Yeah.
fast forward to now, and it's believed to be possible, and we're about to find out. We're on the cusp of finding out what all it can do. That's really cool. And one of the part of it is the camera stuff. So it's got a goal of kind of observing Mars at a distance where the rover is on the surface, the helicopter delivered by the rover, lowered by cables, and then launches on its kind of program schedule, or flies on its program schedule. It's kind of the first time we have an eye in the sky at that level. And so it's kind of observational in what it's working on too, right? Like kind of what are the goals of Ingenuity once it arrives?
Yeah. So first and foremost, the goal for Ingenuity is to demonstrate successful takeoff, controlled flight, and safe landing.
Right.
And really initially it's all about that. I think you mentioned earlier, right? The plan is for it to complete about 5 flights.
Right.
And those flights will be incrementally more and more ambitious. So yeah, really it's, the goal for the vehicle is to collect as much engineering data and telemetry as it possibly can to prove the viability of this as a means of exploring Mars,
Mm-hmm.
And to really seed the future designs for larger rotorcraft.
Yeah.
And hopefully we'll get, as you mentioned, get some awesome imagery
Right.
along the way.
Yeah. And we call it, a Mars helicopter, rotorcraft. The closest thing I can think of, on a consumer level, in terms of the product is like, consumer drones or professional drones. And those are, you talk about what you can do. You can't control it from Earth by joysticks because of the transfer, and the distance. But how similar is it to what you'd see in a consumer drone these days, minus the way that you control it?
A lot of the electronics and software, at least at a conceptual level, is pretty similar.
Mm-hmm.
Obviously, the dynamics of flying in the 1% atmosphere are very, very different. So,
Sure. Yeah.
so there's a tremendous amount of work that went into characterizing those dynamics in the JPL 25-foot vacuum chamber. So that aspect of it, not so similar. I think I would hesitate to compare it too closely to an Earth-based drone,
Sure.
just because of the fact that this vehicle also, as I mentioned earlier, has to be a spacecraft. So there's so many of those space flight requirements that work their way into really every aspect of the design, from maintaining a very tight power budget to keeping things warm through the extreme Martian environment, surviving radiation. So it's it does end up being a quite a different type of vehicle.
Yeah. And something that excites me is that you're working on this now. You're about my age. We're kind of young, and you think back to 24 years ago or so, and what was possible then. Fast forward 30 years. Even 10 years from now, we hope to be much more capable of what we can do with Mars and what we can know about Mars. Something that excites me about what you're doing is that there's like sci-fi movies and there's entertainment, but then there's like what you can actually do, and in a lot of ways it can kind of go under the radar, but it's like real life sci-fi. It's like science without the fiction. You're like proving, it's a proving ground of what you're doing. It's a test flight, and so kind of the next step on this is you prove that it works. You hope to replicate it in larger and larger forms and be more capable. I imagine in 1996, you may not have been able to imagine this, but what do you imagine, in 20 years from now, what could be capable if this goes well?
That is that's a difficult question, right?
Sure.
You're absolutely right that the rate of the technological progress only increases, right? So extrapolating into the future, I imagine that there are all sorts of things possible that we can't imagine today. funny enough, you mentioned that 1990, mid 90s,
Yeah.
no one would have conceived of actually flying a helicopter on Mars. I actually heard about the Mars helicopter concept the day I was interviewing at JPL, and
Oh,
even then
wow. Cool.
I couldn't quite quite comprehend that was possible. So yeah, it really goes to show that, yeah, as the technological building blocks come along and people really start trying to put them together, that you find these remarkable possibilities, like the Mars helicopter.
Yeah. One more thing on the team. Can you kind of describe, how you work amongst yourselves? What is the teamwork like? How many people work on this project? I think it's pretty small, but compared to some other projects, maybe. But can you kind of give us some insight into the people behind the Mars helicopter Ingenuity?
It's certainly it is a small team. It's a very, very passionate team, very, very motivated team. And organizationally, I think it's a little bit different from your larger spacecraft development teams, in that each and every one of us really got to wear a lot of different hats, play a lot of different roles. Just because it was a small team, there's a lot to get done, so everyone had to chip in different places. And being a small team, I think the rate of work was also it was high, right? We were very, very closely connected with one another. We meet several times a day, hash things out on whiteboards, address challenges as they came up right away. Yeah, it's been a very intense but very, very rewarding experience working with these folks.
Awesome. Some easy questions before we head off. When I'm writing stories or doing research, I often listen to either podcast or music, and it just changes what I can do in terms of like my focus. When you're like working solo on your own, what is your kind of, how do you focus? You drink coffee, do you listen to a certain kind of music, or what does that look like for you?
Certainly a lot of coffee.
Yeah.
Yeah, I do like to listen to music as well. Sometimes I think I like to, when you're really, really sort of stuck in a difficult problem, and I find that it helps to sort of find inspiration in thinking ahead, looking ahead to what this thing is going to become. So, I've certainly looked ahead to the upcoming month on Mars, and
right.
flying for the first time, having that Wright brothers moment.
Yeah,
as you call it.
that's awesome.
Imagination, right? Or daydreaming, but
Indeed.
yeah, finding that inspiration, I think, is really, really, really important to motivate you to go forward.
That's awesome. What will you be doing on Thursday, July 30th, when this rocket takes off and begins the journey to send both Perseverance and Ingenuity to Mars?
Well, I'll certainly be watching. It'll be very early here.
Yeah, you're in Pasadena, right? So
yep, in Pasadena.
So
very early in the morning here.
Like 4:50 is the launch time, I think, for you.
Sorry.
Like 4:50 a.m. is, I think, the launch time. Yeah.
Very early, but I'll be up. I'll be watching.
Yeah.
At the same time, we'll also we'll be ready. Getting ready for our first ops and cruise. Still, scheduling and planning to get ready to turn the vehicle on for the first time a few days after launch. So
yeah. That's such useful insight in that there is so much work to be done between now and February, before that kind of moment of truth of what's possible, and even watching the launch casually of like, there goes a rocket launch and it's got some cool technology on it, for you and your team. It's like this is the next step of the process, and there's months of more work to be done. I love knowing that, because before I just thought, I guess it's, now the work is done and you just send it and see what happens. But it's good insight to know that there's much more to be done before then. And then come, February 2021, what does it look like? Is it kind of all hands on deck, or you're all together? How do you think you'll feel then? And what does that kind of getting together look like?
it will be all hands on deck for sure. As soon as the rover lands, it will begin sort of its process of checking itself out, making sure that everything is functional. But what we'll be doing is we'll actually be looking for our flight zone, right? Because the rover's going to have to drive somewhere that's a good candidate for us to fly in. So we'll be looking at orbital imagery. We'll be looking at the rover imagery, literally counting rocks, trying to assess their size and looking at slopes. It's going to be an intense process once we get there.
I love that. As much as it has to be autonomous to achieve its goal on Mars, there has to be so much human input every second of the operation. I love that. Knowing that it's not just out there and we'll see what happens, but there's also so much human input that determines what happens even then. That's awesome. Well, Jaakko Karras, thanks so much for talking to us today. I really enjoyed this.
Yeah, thanks so much for having me on your podcast. This is great.
Absolutely. All right, take care.
Thank you.
All right, that is Space Time for the week. If you enjoyed this episode, please subscribe to Space Time in Apple Podcast, Overcast, Spotify, or on YouTube. And if you enjoyed the episode, give us a review or a rating. We really appreciate that. We're a brand new podcast, and really appreciate anyone who gives it a listen. I'm overjoyed at the people that we're able to talk to and the things that we're able to learn. And so if you are too, please give us a boost. We really appreciate that. With that being said, we will be back next week. Bye, everybody.